This is an exercise in line of soundings navigation, depth sounder navigation. It's and I'm going to work an example from our workbook, and I'll put a link to our navigation workbook in the description. But here's the problem. You are presumably is pea soup fog, and you are down here somewhere in this area, and this is a lighted buoy, and apparently there was a time when it got clear enough you could basically see that, and this was somewhere to the north of you. It doesn't say exactly north, but somewhere north of you, and you estimate roughly from what you saw 1 to 3 miles. And so that's sort of all you have to go with at the moment. You got your E-chart program is working. Now, I'm actually going to do this on a paper chart, all on a paper chart, but I'm going to come back and do another video where you do it with your electronic charting program that has no GPS. You've lost your GPS, but you still have the chart program. And so we can do some tricks that way. But this way is all paper, old-fashioned paper charts. Okay, so and so when we're driving along here, then after that observation, this is explained here. After that observation, we noticed that our sounder went from somewhere around 20 to 70 very quickly in a few minutes. And so that gave us the idea to look ahead to this, see we're somewhere down here, and our course or speed is 6 knots, and our course is 110, something like that. And so we know we're going to be going across this bank, and so the idea is to do some depth sounding to find out where we are. And so then you have to review here. Well, it's not in the exercise. The exercise just assumes you've done all this right. You know that you first of all confirm there's no expected strong currents. Strong currents throw off this technique, so you have to be sure there's no real strong currents, or you have to do more navigation otherwise. But let's say now no currents. You look up the tide, so you know the tide height, you know the draft of how deep your sounder is below the water, and so then we can figure out from what our sounder reads, we can then make these two corrections and get what the charted depth should be. And so then we make this table as we proceed on a steady course, 110 true at 6 knots. Then we have the times here. But more important, when you're doing this type of log of soundings, it's really a lot simpler if you record the log reading. It's like a trip log. So set the trip log to 0, and then you read the sounders 93. And then when you look at this chart here, you see that the two sort of bordering contours of this bank are 50 fathoms and 20 fathoms, and we see that's pretty prominent here. So we're going to just concentrate on the 50 fathoms and 20 fathoms. So we want to, as we proceed, then we're going to start this process, and we're looking at the clock. We read 93. We read 93 fathoms where we are. Obviously, we have a good depth sounder. It's good that you get 100 fathom sounders these days, no problem. And so we read that. And so what we're going to do is make a note every time we hit 50 or 20. But then also looking at this, we see that going across this bank, the shallowest really group is 11, about 11 fathoms. So we'll note 11 when we see it as well. Okay, so off we go. We don't know where we are. We're just looking at we're holding a steady course, steady speed, and we're reading the sounder. So when and we're starting at 93. After we've gone 1.03 miles, we do see 50. We write the 50 down at 103. Then we see a 20 when the log is 123, and so forth. So you fill out this table. So now with that table, our job is to go back and figure out where are we. Again, we have no GPS. It's pea soup fog. We can't see anything. Well, we saw the last thing we could see a while ago. And, prior to the GPS days, this was actually not an uncommon navigation in this part of the world up here. I've done it many times back some years ago, in this exact area. And for those folk, for that, it's really nice. We have all these banks, which are like sawed-off islands. That's another. We'll come back and look at that. But they're very interesting bathymetry. Okay, so now let's go to the problem. And I will just move this away and move this problem away, and I'm on the wrong page here. So we want to start, what you started is with a transparency. So, okay. So first of all, we have to know that from the beginning to the end, we meant 5.48 miles in direction 110. And now this is a sheet of transparency paper. And so I can take the chart scale. Where I get this scale here is exactly the scale from the chart. It's over here on the chart scale. I get my miles scale. Okay. Let me show this. I get the miles scale right from here, the miles scale. And so that's where I get the scale on my chart. This is one program. You can use OpenCPN for this. I'm using, at the moment, QTVLM. You can use any eChart program in that case. But okay, I'm back up. I'm just simulating a paper chart. This is all paper chart solution. Okay, and I'm just illustrating how you would do it, and then we'll have a little bit more on this later. So I'm on a piece of transparency. I draw a line. There's this length, and these are the scales I get with my dividers for each of these distance. 1.03 miles up here. No, we start out with a 93 fathoms, and then I go down. That's a mark here, right here. That's a line, dot. And then I have a 50 fathoms at 103. This is like 1, 2, 3, 4, 5 miles. And then I also plot here. So I don't care about these other lines here. All I care about really is the starting. Well, I don't even care about the starting point, frankly. I care about where these lines are here, these fathoms, these marks here. And I mark them on the scale just like that. And that's on a transparency. Now then, I take that transparency, and again, this is all kind of mocked up to show, let's see here. I take that transparency and I move it over here. Now, think of this as that transparency. I'm moving this transparency around. Now, what have I done on the chart? On the chart, I take a highlight marker. You wouldn't use black, but I mean, this could be like orange and pink or something like that. And I highlight the contours that I'm going to be using. And that's the 50 and the 20. And these are, it's like, there is no 11 sounding contour, so I just kind of sketch in where 11 fathoms and a sounding looks like. So these are the contours. Then your job is you take your line of soundings here, and I'm just moving the transparency paper, and you move it around to where they match. And let's see here. Let's see what we've got. Okay, now that's actually pretty good. Look here. I got the red and the black, right on the red and black. I got the black. I got the red. This is, well, it's not inconsistent, but we don't know very precise, but it's definitely consistent. And then here I got the red, and here I got the black. So that is basically, and the argument is, and so you would say your position is right. Your position at the last time, I think it's 1409, your position is right here. You're just coming on to this Partridge Bank 20 contours right at this point. So that's your fix. Now, there's some uncertainty in that, but if you look around here, you see it's not, look at that. It's just pretty homed in on that. When you try to move this around, there's not going to be many places at all that those lines fit. And so there you go. That's an example of using a piece of transparency on a paper chart. And I actually have, and so I'm going to make some more videos about this, and then I want to show how you would do it if you're just doing all electronics. You've got no GPS. Obviously, you got GPS. You don't need any of this. But but if you lose your GPS, it doesn't mean you lost your charting program. Is still a really powerful tool. All right, so that's the end of that demo.